Hello and welcome to the Chanda Academy. In today's video, we are going to find the domain of definition of this logarithm function. The domain of definition will be the set of x's which are in R, such as there is no problem with this expression, which means that f of x exists. What could be the problem? We see that here we have a division, and so we want this to be different from 0. And then, what do we want? We also want to have something inside of the logarithm that is strictly positive. Let's start. So what we want to do is to study this function and to find all the points where this is positive, such as x squared minus x minus 6 is different from 0. Let's do it. Start. First, we will study the denominator, okay? The denominator, so study of x squared minus x minus 6. So this function, let's call it g of x, okay? G of x is a polynomial. This is a polynomial with a positive coefficient on the higher monom, which is a monom of degree 2, which means that its graph will look like something like that, okay? And so the negative part of this function will be between the roots x1 and x2 if this polynomial has two roots, okay? And this will be the case, we'll see that. So let's find the solutions to g of x is equal to 0. We've got delta, which is equal to minus 1 squared, so this minus 1 here, minus 4 times 1, so 4 times 1, because here there is a 1, times minus 6. And we can simplify those two minus, and we are left with 1 plus 24, which is equal to 25. And the two roots will be x1 is equal and 2, which are equal to minus 1. So 1 is a plus or minus square root of 25 over 2, which is equal to either, when there is a minus, 1 minus 5 over 2, which is equal to minus 4 over 2, which is equal to minus 2, or 1 plus 5 over 2, which is equal to 3. So there are two solutions. x1 is equal to minus 2 and x2 is equal to 3. And so we can say that the graph is something like this, is minus 2 here, 3 here, and the graph of g goes like that. And so that between minus 2 and 3, g is negative, and this is positive outside of its roots. Now let's study x minus 1. So we want x minus 1 greater than 0, strictly greater than 0. And this is equivalent to x greater, we want to find when x minus 1 is greater than 0. This happens when x is greater than 1. And with these two, and of course, x minus 1 is equal to 0 happens in x is equal to 1. And knowing those two things, we will set a table of sign of this function. Okay, so table of sign of x minus 1 over x squared minus 6x minus x, minus 6. We've got it like x going from minus the infinity to plus the infinity. We've got the sign of x minus 1 and the sign of x squared minus x minus 6. So what are the important points? Important points are minus 2, 1, and 3. Because in minus 2, we've got this thing, this will be equal to 0, in 3 as well, and in 1, this is equal to 0. And now, what happens before minus 1? Before 1, we've got this thing that is negative. So after, this is positive. For g of x, we told it earlier, this is positive outside of the roots and negative inside of the roots. And so, what happens to the division of both? The division of both, which is x minus 1 over x squared minus x minus 6, will be undefined here because we divide by 0, undefined here because we divide by 0. It will be equal to 0 here, and here we've got minus times plus is equal to minus, minus times minus is equal to plus. Here we have a minus, and here we have a plus. And we see that this thing, we are looking for it to be positive. We want it to be strictly positive for the logarithm to be defined. And so that happens between minus 2 and 1 excluded, and it happens after, so union, this is the reunion of two sets, and after 3, so 3 to plus the infinity. And this will be the domain of definition of f. So let's call it D first. D is this set, okay? So we've got x minus 1 over x squared minus x minus 6 greater than 0, and this also saying that this is defined, is equivalent to x in D. And that implies that the domain of definition of f being this function, the domain of definition of f is equal to D. And this is equal to minus 2, 1, excluded, union, 3, plus the infinity. And we have solved our exercise. Hope you enjoyed the video. See you soon. Bye.